Here's a little history lesson, and we'll return to these people in the history section of the class. The first one, of course, is Claude Louis Marie Henri Navier. And there's a bust of him in France, right there in the picture. Unfortunately, working with a Frenchman, I don't speak French, Francophone, and we were unable to locate an oil painting of him. If anybody can find an oil painting of him, I'd be really pleased. We've written municipalities and had some students in France travel around trying to find an oil painting. I've written letters and emails, and I can find nothing. I have found many documents and writings of his, but no painting of what he really looked like. But I think this statue is probably really close. He was really an engineer and physicist and a civil engineer who lived between 1785 and 1836. A short life. He's known today mostly for the Navier-Stokes equations. He went to the École Polytechnique in 1804 and studied at École Nationale de Pointe des Chausses he graduated in 1806. And he was known for bridge construction. And in this class, I'll try and show pictures, or at least drawings, of some of the bridges he's designed. He became a professor at the Mechanic School Polytechnique. And if you go to the Eiffel Tower today, which most people do when they're tourists in France and Paris, he's one of the names on the Eiffel Tower. So try and find his name next time you go there. In fact, if someone sends me a picture of his name on the Eiffel Tower, it would just really make me happy. And I would post it on my class and my personal website. The other person the equations were named after were George Gabriel Stokes. And he was a physicist and mathematician in fluids and optics. He was a prolific mathematician. And there's many interesting stories about him, his family, and his life. He spent almost all his career at University of Cambridge, and he became the Lucasian Professor of Mathematics. He held the Lucasian chair just like many other famous people have, like Isaac Newton and George Bidell Airy, Sir James Lighthill, and other notable figures. President of the Royal Society. Interestingly, he was an extremely religious person, and he became the president of the Victorian Institute, founded to defend Christian principles against challenges from evolutionary thinkers in biology. Later on, he married Mary Susan Robinson, daughter of a reverend, and had 5 children. He's famous for an extremely long letter written to his wife, or soon-to-be wife, about why they shouldn't get married. Well, she wouldn't have anything to do with it, and I think he was quite happy with some domestication and not being a calculating machine, as he wrote. I have to put up this quote from Dr. Ferry Farasat, who was a senior technologist and one of the top thinkers at NASA. I worked for him for a time at Langley, and he would often say that the purpose of theory is prediction. I think it's really important to put up this quote before having a series of videos online like in this class. And that's simply because a lot of the work we're doing is theory. It's theoretical and analysis. But the point of all this is to make predictions for the benefit of individuals and society. So keep this in mind when we do deep diving down into pages of mathematics to do analysis on the Navier-Stokes equations. The purpose of theory is prediction.